So let's start with the great road to fame. So Fame is a product that we have built. So Fame is a sister concern company. I am from To The New Digital. It's India's IT company. We have almost, I guess, 170 plus Groovy Grails developer working at To The New Digital. And I'm here to present a talk on Fame, how we built and architected this application, and yeah, how Fame flourished and is faring. So, something about me. Who am I? So my name is Chandan Luthra, and here's my Twitter handle, some LinkedIn profile, and representing To The New Digital, lover of Groovy and Grails. So I've been working with Groovy and Grails from last 7.5 years. And I've authored a couple of books on Firebug Starter, and the 200-page manual, Firebug 1.5. I've also authored some, articles on Groovy Mag. The Plugin Corner series was, I was the guy who was running the Plugin Corner series in the Groovy Mag, and some of the articles in JS Mag also. So, the architect of metrics. So I'm the architect of this Fame application. So let's start about with the Gartner news. So Gartner, I guess in December 4, 2014, Gartner predicts that live video broadcasting would be the new selfie by 2017, and this made our life hell. How? I got a call from my group CEO, and he told me that, hey Chandan, we want to make something that is a small mobile application where a person can broadcast his talent to the world and everybody can see. And I thought, okay, so what's the timeline? He told me, like, I don't know, but couple of months. So after this report, when this was published, and then again got a call from my CEO, not the group, but the local CEO, and he told me that, hey Chandan, see, we have already told you that we'll be developing something sort of this, and Gartner report is out now. Then what should we do now? Then after some time, Twitter launches the Periscope. On March 26, 2015, Twitter launches Periscope, and we only have a couple of months to develop an application which can broadcast live videos and stream videos from mobile. So Fame launches in India. So we started working on December, and after 3 months of development, an MVP was out. It was having some interaction, some chat, and some cool stuff, having live video performance. So we were live like 15-20 days after the Periscope was launched, and this Wednesday, this April 8th, Facebook Live has launched its product. Now you can never leave. Yeah, so there are some facts. So Periscope was initially launched with iOS only, but in May 26th it was launched with Android, and Fame was launched on 15th April, and we were on both Android and iOS. So it was the mobile first application. We target the mobile platform first, and later on in December we target the web platform. So it was a huge duration between the mobile launch and the web launch. So here are some terms that I would be using. DVR. So it's all about the video domain terminology, apart from the Groovy Grails Java stuff. So DVR, it's a digital video recorder. It is similar to the recorder that you have in homes, the set-top box, which record the live streaming videos and resides in the application and resides in the set-top box memory. Encoder Encoder is a software program, or it can be hardware too, which compress the video to a standard format, so that it can be streamed over a network. Transcoding. Transcoding is similar to encoder. So converting a given video input into a digital format that is compatible with most our devices and web players. So some transcoding part is done. So what we are doing here is okay. Next is RTMP. Everybody knows the real-time messaging protocol, and there is also one promote protocol, RTSP, the real-time streaming protocol. I guess everybody would have heard about this. HLS, we have used HLS protocol for streaming, for broadcasting the videos. It's the Apple's protocol. Its full form is HTTP Live Streaming Protocol. So the protocols like RTSP or RTMP works on UDP, Unreliable Protocol, but this HLS protocol works on the HTTP streaming. So it's a TCP/IP protocol-based streaming. OTT platform. Over-the-top delivery of audio and video over the network, over the internet, similar to YouTube. Beam. So this is our term that we have given to the stream. So when we talk about streaming in the FAME application, we talk about beam. Like, what is your beam? What's the beam name? What's your title of the beam? And the last, there's adaptive bitrate. So you must have seen that whenever you have a low bandwidth, the video quality from the YouTube coming from YouTube gets degraded. So this is known as the adaptive bitrate. It automatically adjusts to the video quality depending upon the bandwidth. So here are the contents that I'll be discussing. What is FAME? The need, the solution, some key components, evolution and the future of the FAME. So here's a little video that I'm going to show. I don't know if voice will be audible with this HDMI port or not.
Sholay being the greatest film ever. And then there is, of course, a film called Pollution. I don't know if you've seen it with Mahmood Saab and also. These three films I really like. And recently...
this is the audio. Where
I know I like lots of films. I like
beaming
many more than 5. But Jaane Bhi To Yaaro, I really loved while I was growing up. And
so this is a recorded video, but at the time when he was beaming, so the viewers were getting interacted with him through some chat and stickers, so that they can ask questions like, what's your upcoming movie and how would you feel about the upcoming movie and all.
And she says, hi SRK, my earliest and most favorite memory of films is of you as Vicky in Bazigar. What personal memory are you a fan of?
Not from the film Bazigar, huh? Just otherwise, in person. Okay. Supriya.
Yeah.
Hi.
So yeah, this is the video. So the idea was behind the app was to make it more interactive and user friendly, so that anyone can go live with a simple click of a button, and his stream is talent to the world and the viewers. So in few words, FAME is a platform that allows users to broadcast themselves live. How FAME is faring? So we have 3 million plus monthly average users and 170K plus daily average users. Watch hours, so like this is the total watch hours that everybody is watching a video. It's more than 70K plus, more than 70K per day. So here are the total followers, 4.5 M. Interactions include chat, the stickers, and the likes, the dislikes. So the total interactions are 15 million per day. So, and we have launched in multiple countries. So India was the first, next was the Indonesia, and the third one is in Thailand. So we have presence in all these 3 countries. Some key milestones. So some Bollywood events we covered, some entertainment events, some brand promotions, and some movie promotion and celebrity shows. These all were the things that we achieved in the milestones. So I'm discussing about the need. So the vision was like FAME approached TTF to the new digital. The FAME is our sister concern company, as I already told you. It approached to the new digital. To the new digital is the software development company to build a live video platform with an aim to disrupt and democratize the talent discovery system. So the thing behind to develop this application was like you have heard about the many reality shows, many the talented shows, like some countries name an idol like Indian Idol, India's Got Talent, so you can dance, so you think you can dance, so sort of this stuff. So us group CEO wanted to democratize the app and break the monopoly of these systems, so that people can broadcast their talents, and instead of talent approaching the opportunity approaches the talent. So this was the idea behind the scenes, and we will also see how this happened actually. What FAME needed: a mobile platform in the starting, where user can beam, highly interactive and social, ability to watch previous content, like whenever you beam, you can watch after the beam is over, you can watch your VODs, the video on demands, and the archival stuff. Personalized content, views on web behavior, yeah. So we have also did some personalized content. We served some personalized content after some recording the user behavior, the patterns we saw. So, and the regionalization, like if I'm in India, I want to see some local stars. If I am in Spain, I want to see some local stars of Spain, so that I can interact them easily. So this was done. And international reach yet hyper local, yeah, this I already told you. Challenges: small turnaround time. So MVP was like proposed in less than 3 months. So at that time we were like, hey man, how can 9 women can deliver a baby in 1 month? So the challenges were like minimal latency and adaptive quality, real-time chat. The last one was the very difficult for us, the early mover dilemma. So at that time, when we were developing the application, we don't know about how and what would be the scale of the application, how user will react, what all technologies we need to use, because we were never into a video domain. So we don't know about the technologies and the other stuff, how to proceed with that. So the solution. So from here the things get pretty good. So let me show the solution that we have built. I don't know if internet is working. Internet is not. Soren, are you able to watch the video? Mostly zero. So Soren has volunteered himself to stream the video, so he was streaming live, and I was about to show the video of what is happening around here in the application. So this is the web interface. Let me see if we can see some other video. It's really very slow, dead slow almost. So let's continue with the slides. So this is the story so far. We have launched in the April, May last year. Then we have introduced some stickers, some hashtag, carousel control. In August and September, we revamped the go live experience. 17 on the videos was there. Oh, that was the video. Let me see if I can pull it. Oh, so here the lady is singing something in Hindi. So this is the live video that these guys are streaming from their house, and let me just see if I can pull up the chat. So on the right side, you can see that the viewers are getting interacted with them. Please play my song. This song, they are requesting their songs. Okay. Not the good voice. So here was the initial solution that we have built. So we used the Grails plugin architecture and developed a common application which was having a API, a stream module, a email module, a media one, a web module for serving static content like your terms and conditions and all shit. So, and a job module where jobs are running, some chat module, and a CMS to operate all the backend of the system. And RabbitMQ, we have chose Hazelcast for caching the services, caching the objects. MySQL for storing the metadata of the information users and the beams, and Mongo for logging all the activity around what is happening, like chat, sticker gifting, everything. So thought behind the scene was API first architecture. We were to launch a mobile application first. So the thought was like we have to go with the API architecture. We chose Grails. Why? Because of its rapid application development and good support for REST. Wowza server. Wowza is a streaming engine. It's having a good support for protocols, many protocols, and it's having a mature community and the support too. PubNub. Is anyone using PubNub here? No? So, so PubNub, it's a leader in chat and instant messaging. So we have used PubNub for real-time messaging and for delivery of chats and stickers. Multiple data sources like MySQL and MongoDB, I already told you. So this was the learning. Database that can quickly become point of contention. Like we were running out of connection pooling, and it was really getting difficult to move fast with the monolithic architecture. Monolithic in terms of, not in terms of the jar files, but in terms of the code wise. So the code was like in a Grails plugin based architecture. So the maintenance was getting difficult day by day. And business wants us to move fast. Why? We already see about the Gartner report. That's why business wants us to move fast and fast. Then we design, we build, we test, we deploy, and we learn that this won't work. Now what? So in phase 2, what we did, we just pushed all the architecture behind and introduced some microservices for serving home screen. So like two microservices for serving home screen. One for live, where the live content is shown, and one for VOD, where the archival content is shown. So home screen has got 2 tabs, and 2 tabs are so behind the scenes. Each tab is having its own microservice. And some detail page. So whenever a beam gets over, whenever a live beam gets over, it switches to the landing page. The next landing page is beam details. So the load was heavy, and we thought we should have a separate microservice for beam details. Then again, some smaller chunks. What was the actually thoughts behind the scene? The smaller chunks of application should be easier to manage. Yeah. So the Spring Boot application with Groovy code was easy to handle instead of a monolithic code. Expanding teams will be easier as the smaller teams can work on a smaller project, smaller microservices, like a two-member team can work on one microservice, and you can get productive from day one. And instead of getting him if you explain him all of the architecture, you will get what I say. It will take time to ramp up the developer. Database load distribution archived partially. Yes, since we have a single database, MongoDB, and the other one was MySQL, so distribution was partially achieved, but not all of them. Since we are using different DBs for each of the microservices, so partially we try to achieve the distribution of the database connections and all. And we learned some more things. If not done properly, microservices can be dependency hell. Yes, they can become a dependency hell. Why? Let me pull up an example. Okay, so there is a authentication API that is running on the main servers, the API servers. And I have another microservice for home, which also needs an authentication. Then how will you have a main authentication module serving all the parts of the microservices, all the microservices actually, the API one and the home screen one. So we have done it through caching, and later on we will be moving on to Nginx for serving the authenticated for APIs. Few times consuming transactions can result in bad UX. Yeah. So the time-consuming transactions could become a hell when it comes to mobile UX, because whenever you see an application which is taking time to load, you go and just install the app. So user engagement was not proper, and we thought that the turnaround time of the API should be less than 40 milliseconds, so that we can have much more user base and have them retained in the application. Performance tuning requirement, thing to scale. So the performance tuning. So after the launch of the MVP and the launch of the phase 2 with the microservices, whenever we got a requirement, we automatically started thinking in terms of performance tuning. Like, if I send a chat, how fast can it get delivered? What should I do? From where the data is? From where can I get the cache data? And instead of making a call to DB, and from where I can reroute the message so that it can deliver faster and faster. And we need, of course, more database connections to scale up the things and to handle the load. There are better ways to do calculations and aggregations. So we were doing some calculations and aggregations using the MongoDB, the aggregator tool of the MongoDB, but still there are many things. Then let's see what we did. Then again, we learn, adapt the things, design, build, test. So this is the next solution. This is the current solution that we are using, not this one, the other one. So this was the stage 2. So what we did in stage 3, we again package this in stage 2, post it, and introduce some Spring Boot microservices for some more pages. For video detail page, for chat, we have launched the chat new version. And yes, for calculations and aggregation, we use a big data stack which comprises of Spark on Yarn, yet another resource negotiator, and the backing up with Cassandra. So by using this, we were able to calculate crores and crores of records, millions of records, I can say in longer less than 1 or 2 seconds. So it was the real-time calculations was done on that was done by Spark and was getting stored at Cassandra. And yes, we launched our web module, the web interface, through AngularJS because we already have an architecture which was built on the APIs, an API-related architecture. So Angular was the best fit for us, so that we can reuse those APIs for serving the web interface. So APIs are common for web interface and the mobile interface. Existing APIs made AngularJS as obvious choice for our web. Offloading certain calls to Nginx for smart response caching. Yeah, we learned that we should, offload some calls to Nginx, where we were doing some, asynchronous tasks. We thought we can, offload those calls instead of JVM to Nginx. How? If I say we were logging the watch seconds. So whenever a user is watching a video, we, hit an API that user has watched this video for this much of seconds. But we don't want that call to be real time. So what we did, we offloaded that call to Nginx, and Nginx then reroute that data to RabbitMQ through curl call after scripting it on a Perl. So we have a Perl module in the Nginx installed, and the Perl module we written a couple of lines of code which uses curl command to reroute the data to RabbitMQ, and there were RabbitMQ listeners behind the scenes who were continuously listening the RabbitMQs and were dumping the data. So by this way we were able to handle the load of the watch seconds. So like thousands of watch seconds call per second. I don't know will JVM would be able to handle or not. Hazelcast. So Hazelcast is again a caching server, can handle some complex queries as well. So we have also learned that instead of storing some objects and retrieving some object from Hazelcast, we can also use it for fetching the objects, for fetching the data that we want. So you can pass a Pojo with a query, and it will revert you whatever he can find. It can find in the cache and filter out the data. Okay. Spark level, server level optimizations, improves performance from hardware. Yes, we also did some, hardware level optimizations by increasing the I/O limits of the servers and by increasing the U limit and the TCP/IP transactions, TCP/IP limit, I/O limit, so that we can, we can serve multiple calls at the same time. So, and we also used Jetty. We replaced Tomcat with Jetty. So I don't know why, but it worked for us magically. I was like stubborn when it came to change for when it come like we have to use Jetty instead of Tomcat. But Jetty proved to be more better and far more faster than Tomcat. Spark, Kafka, Hadoopian, Cassandra combination good for real-time and batch aggregations. And yes, we have used Docker in our development environments, and we will be soon be moving it into production environments sooner by, I suppose, August. And the learning continues. 150 plus servers are on 5 different environments. So we have got some QA, 2 QA environments, 1 UAT environments, 1 load environment where we can, test the load. We can do a load testing, and 1 production environment. So all of total are 150 servers. In continuation with that, the choice for MySQL, Percona, AWS Aurora, Vitess. I don't know which we will be using, but we are comparing. We are doing some comparison and benchmarking for all the databases. So for sure, we won't be using MySQL, but Vitess, it's a Google product, Vitess. So the backend of YouTube, if you don't know, the backend of YouTube is Vitess. So Vitess is nothing but a cluster of MySQLs where you can make 160,000 write calls per second. MongoDB improvements, we did some sharding and application so that we can have much more scale. Grails 3, we haven't moved on to Grails 3, but we are planning to move our application or some microservices onto Grails 3. Real-time monitoring, we have used some third-party tools for real-time monitoring that I will be showing later in the slides. And a relentless, faster encoding mechanism for live streaming and viewing. So from end to end, when a stream starts from mobile device and gets delivered to the other mobile device, it takes about 40 seconds or 30 to 40 seconds time duration. So we are working on that, and we are thinking of to minimizing it to 10 seconds or 15 seconds. Personalization, nothing. So yeah, here comes the other thing. This is the overview of what we are doing for video domain enthusiast. If you want to know what we are doing nothing but streaming a RTSP protocol, RTSP stream to Wowza Media Engine and generating an HLS and delivering it to the endpoints. So behind the scenes, this is in detail. This is the detailed architecture that we are doing. So from mobile devices, RTMP stream is going up to the Wowza servers. Then the recording is happening. The transcoding is done. So transcoding then generates multiple bit rates, like in 140p, 160p, 240p, 360p, 480p, and 480p is the maximum that we are transcoding. So all the bit rates are then ingested to the Limelight server, the Limelight CDN, and which at the end gets delivered to the mobile application. For serving the VOD content, we are recording the streams and saving it into the S3 buckets. Later on, we are using some hardware transcoder. So Elementor is the hardware transcoder. So what it does, it transcodes all the archived videos into different bit rates, and it stores it in the S3 bucket, from where we used CloudFront CDN to serve it to the mobile application. So here are some tools that we are using for monitoring and optimizations. New Relic, I guess most of the applications are now using New Relic for monitoring. Anybody using New Relic? Okay, 4, 3, 5, 6 guys are using New Relic. So New Relic is a very powerful tool that can reside in your Tomcat or Jetty, and will give you some insights about what is happening behind the scenes, which query is taking too much time, and which call is taking too much time, how many errors are there, and if anything is breaking, it will raise the alarm. So after monitoring the New Relic dashboard, you can for sure optimize your application. Apps Flyer, we are using Apps Flyer for mobile application, and from where we get to know that how many installs are getting done, and how much users are on the application, the mobile application, real time, and you can run some campaigns through Apps Flyer too. So this is the technology stack that we are using in the application. So hell lot of technologies. Even I don't know more than half of them, but we are using. Something that I want to tell you, is anybody using branch metrics in the mobile application? So it's a mobile application tool. It's an open source, not the open source. It's a free tool, like not open source, but it's a free tool that anybody can use in the mobile application, and it helps you to create deep links. So if I share a beam that is happening, like Soren is live. So if I share on some social applications, then a user, after clicking on them, can be directly landed to that page in the mobile application. Or if he's clicking from the desktop website, then he will be taken to the desktop page. So you don't need to care about which page to link and how a lot of complexities are there. So branch will automatically detect and redirect the user to the proper page. And this will really help your business to grow, I must say. We are using some protector for automating the web test cases. Of course, Jenkins for building the tools, building the builds. JW Player, we are using JW Player in the website and the mobile application for showing the HLS content, the HLS video. We have used prediction.io in the past for serving the recommendations, but we just banished that. It was not working for us. So some key components, I guess 4 minutes are left. Some key components, live streaming and chat. This is the live streaming, this is the landscape mode, and that's the vertical mode. How user can see, it's similar to the YouTube, but with a chat, live chat. So these are the technologies that make it possible for streaming and the chat. So for chat, we are using PubNub for delivering the messages. Where is the hell PubNub gone? Oh, there. And search, we have used Elasticsearch in the backend, RabbitMQ for synchronizing the database and the Elasticsearch, Mongo, of course, storing these things, and Grails. Fame Talent League, so it's a contest that we run, and there is some prize money. Every day you can win a mobile phone and the car in quarterly. So it's like how much score is your, and the top scorer gets some prize. So here we use the Cassandra one, the Spark cluster, the big data stack. So, and the Kafka, of course, for communicating between the Spark cluster and the application. So evolution future. So this is the road ahead. Regionalization, we have achieved regionalization for the local contents, but it's not perfect yet. We are working on it. Monetization, we will be starting some gifting options, gifting stickers, so that performer can get something, you can earn something, and user engagement becomes more and more. Collaborative beam, so that collaborative beam is like beam within a beam, a stream, like combination of 2 or 3 streams into a one video. So we are working on that. Some private beaming, like the Facebook and Facebook does, so that you can broadcast to the limited number of people. Gamification, so that you can earn some points and give them gratification for engagement. And anything else? Time for questions. 2-3 minutes left.
Funciona. Sì, funziona. First of all, my best compliments.
Thank you.
I would like to some details on low bandwidth.
Okay. So for lower bandwidth, what we did, we have introduced actually the adaptive bitrate quality in the encoder itself from the mobile encoder, in the mobile application. So what it does, it adjusts according to your bandwidth, internet bandwidth, and there's some formula. If bandwidth is this much, then adaptive bitrate would be this much, and but the quality and the frame gets degraded. So if I say quality degraded, it's like picture will be much more, the video will be much more pixelated, and but audio would be clear, and there will be some frame drops, like a second of frame can be dropped. And for delivery side, this was the upload side, and for the delivery side, we have of course used the adaptive bitrate of Wowza. It provides you the transcoding facilities so that you can generate multiple video bitrate, and depending upon the bandwidth, the player adjusts according to that bitrate. But you should have something, a minimum of like 100 kbps connection to stream and watch the video.
Simply in Italy, out of the great cities, the bandwidth mobile is very, very low.
Yes, yes. So for 2G connection, I suppose you can only watch the videos, but you cannot stream the videos on 2G connections.
Hi. You're using a bunch of technologies there. So how are you doing coordinating authentication? Are you using cookies or sessions, or you've got your PubNub and all these other servers, and they're all working kind of with microservices. So how's authentication, or how are you doing it from a user point of view?
Token-based. It's a token-based authentication. So we are storing a token in the cookies, and we are using this to authenticate the things.
More questions?
Okay, done. Thank you.